MPEG-1 or MPEG-2 Audio Layer III, more commonly referred to as MP3, is an audio coding format for digital audio which uses a form of lossy data compression. It is a common audio format for consumer audio streaming or storage, as well as a de facto standard of digital audio compression for the transfer and playback of music on most digital audio players. The use of lossy compression is designed to greatly reduce the amount of data required to represent the audio recording and still sound like a faithful reproduction of the original uncompressed audio for most listeners. An MP3 file that is created using the setting of 128 kbit per second will result in a file that is about 1/11 the size of the CD file created from the original audio source. An MP3 file can also be constructed at higher or lower bit rates, with higher or lower resulting quality. The compression works by reducing the accuracy of certain parts of a sound that are considered to be beyond the auditory resolution ability of most people. This method is commonly referred to as perceptual coding. It uses psychoacoustic models to discard or reduce precision of components less audible to human hearing, and then records the remaining information in an efficient manner. MP3 was designed by the Moving Picture Experts Group as part of its MPEG-1 standard and later extended in the MPEG-2 standard. The first subgroup for audio was formed by several teams of engineers at Fraunhofer IIS, University of Hanover, AT&T Bell Labs, Thomson Brandt, CCETT, and others. MPEG-1 audio, which included MPEG-1 Audio Layer I, II and III, was approved as a committee draft of ISO/IEC standard in 1991. Finalized in 1992 and published in 1993. Backwards compatible MPEG-2 audio with additional bit rates and sample rates was published in 1995. History. Development. The MP3 lossy audio data compression algorithm takes advantage of a perceptual limitation of human hearing called auditory masking. In 1894, the American physicist Alfred M. Meyer reported that a tone could be rendered inaudible by another tone of lower frequency. In 1959, Richard Emmer described a complete set of auditory curves regarding this phenomenon. Ernst Hart al. created an algorithm describing auditory masking with high accuracy. This work added to a variety of reports from authors dating back to Fletcher, and to the work that initially determined critical ratios and critical bandwidths. The psychoacoustic masking codec was first proposed in 1979, apparently independently, by Manfred Schroeder, al. from Bell Telephone Laboratories, Inc., in Murray Hill, NJ, and M. A. Krasner, both in the United States. Krasner was the first to publish and to produce hardware for speech, but the publication of his results as a relatively obscure Lincoln Laboratory technical report did not immediately influence the mainstream of psychoacoustic codec development. Manfred Schroeder was already a well-known and revered figure in the worldwide community of acoustical and electrical engineers, but his paper was not much noticed, since it described negative results due to the particular nature of speech and the linear predictive coding gain present in speech. Both Krasner and Schroeder built upon the work performed by Eberhard F. Zwicker in the areas of tuning and masking of critical bands. That in turn built on the fundamental research in the area from Bell Labs of Harvey Fletcher and his collaborators. A wide variety of audio compression algorithms were reported in IEEE's refereed Journal on Selected Areas in Communications. That journal reported in February 1988 on a wide range of established working audio bit compression technologies, some of them using auditory masking as part of their fundamental design, and several showing real-time hardware implementations. The immediate predecessors of MP3 were optimum coding in the frequency domain, and perceptual transform coding. These two codecs, along with block switching contributions from Thomson-Brandt, were merged into a codec called ASPEC, which was submitted to MPEG, and which won the quality competition, but that was mistakenly rejected as too complex to implement. The first practical implementation of an audio perceptual coder in hardware was an implementation of a psychoacoustic transform coder based on Motorola 56000 GSP chips. As a doctoral student at Germany's University of Erlangen-Nuremberg, Karl-Heinz Brandenburg began working on digital music compression in the early 1980s, focusing on how people perceive music. He completed his doctoral work in 1989. MP3 is directly descended from OCF and PXFM, representing the outcome of the collaboration of Brandenburg, working as a postdoc at AT&T Bell Labs with James E. Johnston of AT&T Bell Labs, with the Fraunhofer Institute for Integrated Circuits, Erlangen, with relatively minor contributions from the MP2 branch of psychoacoustic subband coders. In 1990, Brandenburg became an assistant professor at Erlangen-Nuremberg. While there, he continued to work on music compression with scientists at the Fraunhofer Society. The song, Tom's Diner, by Susanne Vega, was the first song used by Karl-Heinz Brandenburg to develop the MP3. Brandenburg adopted the song for testing purposes, listening to it again and again each time, refining the scheme, making sure it did not adversely affect the subtlety of Vega's voice. Standardization. In 1991, there were only two proposals available that could be completely assessed for an MPEG audio standard: Musicam and ASPEC. The Musicam technique, as proposed by Philips, CCETT and Institut für Rundfunktechnik, was chosen due to its simplicity and error robustness, as well as its low computational power associated with the encoding of high-quality compressed audio. The Musicam format, based on sub-band coding, was the basis of the MPEG audio compression format. Much of its technology and ideas were incorporated into the definition of ISO MPEG Audio Layer I and Layer II and the filter bank alone into Layer III format as part of the computationally inefficient hybrid filter bank. Under the chairmanship of Professor Mussmann, the editing of the standard was made under the responsibilities of Leon van der Kerkhoff and Gerhard Stoll. ASPEC was the joint proposal of AT&T Bell Laboratories, Thomson Consumer Electronics, Fraunhofer Society and CNET. It provided the highest coding efficiency. A working group consisting of Leon van der Kerkhoff, Gerhard Stoll, Leonardo Chiariglione, Yves-François de Héry, Karl-Heinz Brandenburg and James E. Johnston took ideas from ASPEC, integrated the filter bank from Layer 2, added some of their own ideas and created MP3, which was designed to achieve the same quality at 128 kbit per second as MP2 at 192 kbit per second. All algorithms for MPEG-1 Audio Layer I, II and III were approved in 1991 and finalized in 1992 as part of MPEG-1, the first standard suite by MPEG, which resulted in the international standard ISO, IEC 11172-3, published in 1993. Further work on MPEG audio was finalized in 1994 as part of the second suite of MPEG standards, MPEG-2, more formally known as International Standard ISO, IEC 13818-3, originally published in 1995. MPEG-2 Part 3 defined additional bit rates and sample rates for MPEG-1 audio layer I, II and III. The new sampling rates are exactly half that of those originally defined in MPEG-1 audio. This reduction in sampling rate serves to cut the available frequency fidelity in half while likewise cutting the bit rate by 50%. MPEG-2 Part 3 also enhanced MPEG-1's audio by allowing the coding of audio programs with more than 2 channels, up to 5.1 multi-channel. An additional extension to MPEG-2 is named MPEG 2.5 Audio, as MPEG-3 already had a different meaning. This extension was developed at Fraunhofer IIS, the registered MP3 patent holders. Like MPEG-2, MPEG 2.5 adds new sampling rates exactly half of that previously possible with MPEG-2. While not an ISO-recognized standard, MPEG 2.5 is widely supported by both inexpensive and brand-name digital audio players as well as computer software-based MP3 encoders and decoders. A sample rate comparison between MPEG-1, 2 and 2.5 is given further down. MPEG 2.5 was not developed by MPEG and was never approved as an international standard. MPEG 2.5 is thus an unofficial or proprietary extension to the MP3 format. The ISO standard ISO IEC 11172-3 defined 3 formats: the MPEG-1 audio layer I, layer 2 and layer 3. The ISO standard ISO IEC 13818-3 defined extended version of the MPEG-1 audio, MPEG-2 audio layer I, layer 2 and layer 3. MPEG-2 audio should not be confused with MPEG-2 AAC. Compression efficiency of encoders is typically defined by the bit rate. Because compression ratio depends on the bit depth and sampling rate of the input signal. Nevertheless, compression ratios are often published. They may use the compact disc parameters as references, or sometimes the digital audio tape SP parameters. Compression ratios with this latter reference are higher, which demonstrates the problem with use of the term compression ratio for lossy encoders. Karl-Heinz Brandenburg used a CD recording of Suzanne Vega's song, Tom's Diner, to assess and refine the MP3 compression algorithm. This song was chosen because of its nearly monophonic nature and wide spectral content, making it easier to hear imperfections in the compression format during playbacks. Some refer to Suzanne Vega as the mother of MP3. This particular track has an interesting property in that the 2 channels are almost, but not completely, the same, leading to a case where binaural masking level depression causes spatial unmasking of noise artifacts unless the encoder properly recognizes the situation and applies corrections similar to those detailed in the MPEG-2 AAC psychoacoustic model. Some more critical audio excerpts were taken from the EBUV3 SQAM reference compact disc and have been used by professional sound engineers to assess the subjective quality of the MPEG audio formats. Going public: a reference simulation software implementation, written in the C language and later known as ISO 11172-5, was developed by the members of the ISO MPEG Audio Committee in order to produce bit-compliant MPEG audio files. It was approved as a committee draft of ISO IEC technical report in March 1994 and printed as document CD 11172-5 in April 1994. It was approved as a draft technical report in November 1994. Finalized in 1996 and published as international standard ISO IEC TR 11172-5 to 1998 in 1998. The reference software in C language was later published as a freely available ISO standard. Working in non-real-time on a number of operating systems, it was able to demonstrate the first real-time hardware decoding of compressed audio. Some other real-time implementation of MPEG audio encoders were available for the purpose of digital broadcasting towards consumer receivers and set set-top boxes. On 7 July 1994, the Fraunhofer Society released the first software MP3 encoder called L3ENC. The file name extension, MP3, was chosen by the Fraunhofer team on 14 July 1995. With the first real-time software MP3 player WinPlay 3, many people were able to encode and play back MP3 files on their PCs. Because of the relatively small hard drives back in that time, lossy compression was essential to store non-instrument-based music for playback on computer. As sound scholar Jonathan Stern notes, an Australian hacker acquired L3ENC using a stolen credit card. The hacker then reverse-engineered the software, wrote a new user interface, and redistributed it for free, naming it "Thank You Fraunhofer." Internet distribution. In the second half of the 90s, MP3 files began to spread on the Internet. The popularity of MP3s began to rise rapidly with the advent of Nullsoft's audio player Winamp, released in 1997. In 1998, the first portable solid-state digital audio player MP-Man, developed by C&I Information Systems, which is headquartered in Seoul, South Korea, was released, and the Rio MP300 was sold afterwards in 1998, despite legal suppression efforts by the RIAA. In November 1997, the website mp3.com was offering thousands of MP3s created by independent artists for free. The small size of MP3 files enabled widespread peer-to-peer file sharing of music ripped from CDs, which would have previously been nearly impossible. The first large peer-to-peer file sharing network, Napster, was launched in 1999. The ease of creating and sharing MP3s resulted in widespread copyright infringement. Major record companies argued that this free sharing of music reduced sales, and called it music piracy. They reacted by pursuing lawsuits against Napster and against individual users who engaged in file sharing. Unauthorized MP3 file sharing continues on next-generation peer-to-peer networks. Some authorized services, such as Beatport, Bleep, Juno Records, MMusic, Zune Marketplace, Walmart.com, Rhapsody, the recording industry-approved reincarnation of Napster, and Amazon.com, sell unrestricted music in the MP3 format.